Measures of historical rate of return. To explain the calculation process of historical rate of return, we will take an example of whole green stock returns over several years as shown in this table. After getting the required data of annual stock prices and its dividends, the first step is to calculate the annual holding period return, as explained elsewhere in separate lecture. The table shows the annual holding period returns, both in decimal and in percentages. The return relative is calculated as 1 plus annual holding period return in decimal points. We can calculate the historical rate of return by two methods. First, by arithmetic mean return. Second, by geometric mean return. Arithmetic mean return can be calculated with this equation, where arithmetic mean equal to sum of the holding period return divided by n, which is the number of years. To apply the equation, we will get all of the holding period returns, adding them together, and divide by the number of years, which is 10. This will result in 252.1% divided by 10, which is equal to 25.2%. Geometric mean return can be calculated using the following formula, where nth root of the product of return relatives minus 1. Applying the formula will result in 0.234 or 23.4%. The question here, which one is better? Geometric mean rate is considered superior measure of the long-term mean rate of return, because it indicates the compound annual rate of return based on ending value of the investment versus its beginning value. Although arithmetic mean return provides a good indication of the rate of return for an investment during any 1 year, it has an upward bias when measuring an asset's long-term performance. For example, as we calculated the relative returns as 8.172, this means if you invest $1 in 1994, the whole value, including dividends if they are reinvested, will be $8.172. To further explain the idea of bias of arithmetic mean, let's assume we purchased asset and within 1 year it's doubled or 100% appreciate in value. And next year we lost all income achieved and the asset value returns to its normal or original price as shown in this table. If we calculate both arithmetic mean and geometric mean for this example, we will get the arithmetic mean equal to 25% and geometric mean equal to 0%. The answer of 0% represents the real case scenario, as the value of asset returns to its original value, which is seen by geometric mean calculation. When rates of return are the same for all years, the geometric mean return will equal the arithmetic mean return. If the rate of return vary over years, the geometric mean return will always be lower. The difference between the two mean values will depend on the year-to-year changes in the rate of return. The larger annual changes in the rates of return will result in a greater difference. Most investors, especially long-term investors, don't take a periodical income but rather reinvesting the income. To explain that, let's take this example. Let's assume we have an asset or bond with a value of $10,000 that pays an annual interest rate of 9%, which means $900 per year. This value of $900 will be earned every year as a fixed income. This income is called simple interest rate. Imagine now that at the end of each year, we reinvest the income of $900. In this case, the first year income is $900. The second year income will be $981. The third year income will be $1,069. And it will increase in annual basis till it reach 1,955 in the 10th year. This method is called compounded interest rate. Compounded interest rate or reinvestment will result in a significant income over years, as shown in this graph.